See this, if A is an n by n non-singular matrix, so what do you mean by non-singular matrix? It means that det A is not equal to 0. So what does it mean? It means inverse of that matrix exists. So whenever a matrix is non-singular, you can think that inverse of the matrix is possible and it exists, and also det A is not equal to 0. If A is an n by n non-singular matrix, which means if det A is not equal to 0, then we are supposed to prove this: A transpose inverse equal to A inverse transpose, which is nothing but you are supposed to show that the operations inversing and transposing are actually commutative. Commutative means you can take them in any order. So either you take transpose of a matrix and then inverse it, or inverse of a matrix and then transpose it. The result is supposed to be same. It is interesting, right? So how can we prove it? Let's see the proof. Now we know that, we already know this, right? The determinant of a matrix or its transpose both are equal, which means A transpose or A both are equal, and it is already known that A is non-singular, which means det A is not equal to 0. See, this part we already know it. We have seen many examples also. If you take a matrix or its transpose, the determinant value doesn't change. That we already know that, and it is now given that A is a non-singular matrix. Therefore, from this one I am writing this. So what can we derive from that? That even this one, the A transpose determinant is also not equal to 0, which means A transpose is non-singular. Now since A transpose is non-singular, what can we say? That A transpose is invertible, which means it is going to have inverse which exists. Why is it important? Because see this, A transpose inverse is being found out here. So unless you do this step, you cannot go ahead, because we cannot say that for A transpose inverse exists, isn't it? So now since det A is not equal to 0, inverse for A exists, from that we can say that det A transpose is also not equal to 0, therefore this one. So from now on you can remember that if a matrix is going to have an inverse, then its transpose is also going to have an inverse. Okay, fine. And we know that since A is invertible, we can write like this: A into A inverse into A equal to In. This one is straightforward. And now what I'll try to do is I'll take on all the three sides this transpose. So when I apply transpose here and transpose here, we already know this reversal rule. I think you remember it. A into B transpose is equal to B transpose into A transpose. We have seen many examples on that also, right? So I'm just writing it like that. I'm just applying the transpose and then I'm expanding it out in such a way that I'm reversing, which means A transpose, A inverse transpose into A transpose, and A transpose into A inverse transpose, that equal to In. Got it? Now you observe this. We have A inverse transpose here and A transpose here, A transpose here and A inverse transpose here, right? So now from these equations, you can think of it this way. It shows that if you have a matrix A transpose, right, then we are going to have one more matrix A inverse transpose in such a way that A inverse transpose is the inverse of A transpose. Okay, so I don't think that you are understanding it. What I'll try to do is I'll just try to rename them, then you'll understand it. Okay, now let's call it as B. Let's call it as A, which means this entire part I am calling it as B and this part I am calling it as A, and this one is A and this one is B and this one is In. Now we got that BA equal to AB equal to In. Now what does it mean? That A and B are inverses of each other, isn't it? Therefore we can say that A inverse transpose is the inverse of A transpose, isn't it? So from this equation we can say that A inverse transpose is the inverse of A transpose. This equation shows that A inverse transpose is the inverse of A transpose. Therefore I can write it this way: A inverse transpose is the inverse of A transpose. Now we got it? Are you getting this? A inverse transpose is the inverse of A transpose. Okay, even if you are not able to understand this theorem, if you cannot remember the proof, just remember the result. What is the result? That the transposing operation and inversing operation are commutative. So the order in which you apply the operation doesn't matter. Whatever order you apply, the result is always going to be same. First you transpose it or you inverse it, and then you apply the remaining operation. The result is always going to be same. Okay.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.